This video is going to demonstrate how you can move real numbers into into floating point numbers, sorry. So I'm going to just show you how it works first. Now, you won't be able to do this unless you understand fixed point binary first, so you may want to go back to that video to do this. So what I'm going to do is I'm going to show you with the number 9.75 and how we can normalize that and get that where it needs to go. So what we've got to do is put it into fixed point first. So we're going to go to fixed point. Alright, so with fixed point we've got to make the number 9, we know it's positive, so that's important, alright, and because it's to complement we need to start with a 0, so we're going to go 1, 2, 4, 8, okay, and we're going to go minus 16, alright. I'm doing that for a reason, because I need that to be a 0, this to be a 1, 0, 0, 1, so I've made the number 9 now. Now I know that 0.75 is 3/4, so I've got my half and I've got my quarter. So they're going to be 1s as well, and we're doing this with 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're doing that with 8 bits. So that would be 1/8. Okay, so that's turned off. Now, first thing that we need to do, alright, is we need to have a look at that number, and we've worked out what it is in fixed point. Alright, we know that that is 9 and we know that that is 0.75. Now to normalize this, what you need to do is move the decimal point into the normalized position until it's 1, 2, 3, 4. The first 0 and 1 because it's positive. But don't stop here. This is a common error because that will make the number a negative number. We are going for a positive, so it's between the first 0 and 1. So we've moved that 1, 2, 3, 4 places, alright, and if you move to the left, it's positive, alright, so we've moved 4 steps, which means that your exponent is going to be 0, 1, 0, 0. So we know the exponent is 0, 1, 0, 0, and our number can now be written as 0.10011110. Alright, because if we moved that 4 steps, it would go 1, 2, 3, 4. Which would give us the 9. Just had to double check my answer there, because if I move that there, you can see that that is equal to 9. Alright, so this would be your mantissa. Don't worry, we're going to do another example, and this would be your exponent. Right. They're not all as simple as that, but we're going to go for another one. And we're going to go for the number 5 this time. Alright, so we're going to go for another simple one, which is 5.75. I'm going to work that out in fixed again, so you can see how it is. So 1, 2, 4, 8. So that's going to be positive, so that's going to be 1, 0, 1. Okay, 0.75, again we've used a quarter, so that is 1, 1, and we're doing in 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So it's an 1/8 and a 16th. Now to normalize this, we've got to go 1, 2, 3. So our exponent would be 0, 0, 1, 1, because that represents 3. And our number would now be written as 0.10111100, because you can see when we move that back what that value would be. Now, they're not all as simple as that. Some of them get a little bit more complicated. Sometimes you may need to move the opposite way to normalize it. sometimes you need to move the number to the right to get it normalized, because there's too many zeros at the beginning. So I'm going to show you what happens with that. So we're going to represent the number 0.125. Now, I know that that is equivalent to 1/8. All right. So if I write that number out now, I've got 0.0001. That's 4, 5, 6, 7, 8. To normalize it to the first 0 and 1, I actually need to move that to the right this time. Okay? If you are moving to the right, you will generally have a negative exponent. So what we're going to have to do here is I'm going to write out -8, 4, 2, 1. That is -2. So if you go in this way, it would be a +2. But if you go in this way, it's -2. So we've moved the decimal place 1, 2 places. So therefore, -8 plus 4 and 2, that would be -2. That would then equate to, all right, 0.10045678 as your mantissa, and then your exponent. Sorry, so that'd be 0.100000, and to get that to move back, your exponent would be 1110 to -2, because it is in 2's complement. So have a go at converting some real numbers and see how you get on.